G'day guys, how you going? Today we're going to be looking at our next video series in the next video in the physics series, and we're going to be looking at voltage in series and parallel circuits. So voltage is the potential difference in energy in a circuit, and what this means is how much energy has been lost by an electron between 2 points. Okay, and that's what we're going to be looking at. In a series circuit, voltage is split between the loads of the circuit, and in a parallel circuit, voltage is not split between loads in different paths, and we'll come to why in a little bit. In order to try and make this a little bit simpler, I've tried to come up with an analogy, and we're going to use the Volta Bean analogy. All right, think of Volta Beans as energy. Electrons can carry this energy around the circuit. The batteries or cell provide the electrons with this energy. The electrons can then move through the circuit, carrying this energy with them. So for example, this electron here, you'll notice it's got 2 Volta Beans worth of energy, and it can carry this energy through the circuit. Okay, so let's have a look at this in practice. Let's start with a series circuit. We've got a cell here which provides 2 Volta Beans of energy to the electron. So the electron comes along, it gets 2 Volta Beans of energy from the cell. It then moves through the circuit. Now the electron knows that it's got 2 loads in this circuit, so it needs to split its energy between these different loads. So what's it going to do? It's going to give one of its Volta Beans to this first load. It's then going to move to the second load in the circuit. It's going to give its other Volta Bean to that load, and it is then going to return with no Volta Beans back to the cell to get more energy, basically. And so what you can see is its initial 2 Volta Beans have been split. This load has received 1 Volta Bean, and this load has received 1 Volta Bean as well. We could replace Volta Bean with volts, and boom, you have a perfect description of voltage. Voltage is being split from 2 volts. This load will receive 1 volt of energy, and this second one will receive 1 volt of energy as well. It's being split, okay? So let's look at that in a parallel circuit then. Same scenario. We've got an electron and we've got a cell with 2 Volta Beans worth of energy. Electron comes along, gets its 2 Volta Beans, and it's then going to travel through the circuit. But at this point, it needs to make a choice. It either goes down path A or it goes down path B. And so if that goes down path A, you'll notice that there's only 1 load in this path. There is only 1 bulb. So it is going to give all of its Volta Beans to this 1 bulb. It is going to give up 2 Volta Beans of energy to this 1 bulb. It is then going to return back to the cell, and then another electron, or when it goes around, will take a different path, and it will also only encounter 1 bulb or 1 load on its path. So it's going to give 2 Volta Beans worth of energy to the 1 thing it encounters, and then it's going to return back. So in a parallel circuit, you will notice that voltage isn't split. This is a cell with 2 Volta Beans of energy. This bulb receives 2 Volta Beans, and this bulb also receives 2 Volta Beans. Obviously, replace Volta Beans with volts, and you've got 2 volts of energy going into this bulb, and you've got 2 volts of energy going into this bulb, same as was initially in the cell. Okay, and that's literally series and parallel circuits looking at voltage. I would encourage you to put that into a PhET simulator and have a bit of a look, but I hope this helps, guys. Have a good one.